Good morning to one and all present here. I am Kashish Vishwakarma from Prestige Institute of Management and Research. I am a BTech CIC first year student, and today I am here for the presentation on the topic projection of points. So let's start our presentation. So I welcome everyone to my presentation. Now, here is the learning outcome. So, by the end of this presentation, you would be able to understand about the projection. You'll gain a comprehensive understanding of projection and its core applications and its diverse applications. Okay. Now, you'll also gain about the practical knowledge that in real life, where the projection of point is actually applied. Okay, like it's included in the art, architecture, engineering. So in short, we can say that you can easily understand the concept by the end of this video. Okay, so here is the outline. So our outline of the presentation is going to be about the projection. Then we'll understand the projection of point and its notation, then types of projection of points, and then the application of projection, and then you'll understand the conclusion. Okay. Okay. So before coming to projection of points, you should know that what is the projection. Okay, so projection is just like an image, या फिर we can say that it's a view of an object. Okay, so when the view of an object, we can say that projection is the process of representing a 3D dimension 3D, or we can say that three-dimensional object into a new dimensional surface, capturing its form and position. Okay, if I talk very straightforward, the what is projection? It's just a view of an object. View means that we are having a plane. Okay, now here you are going to get the view. So in between you are having the object, and then when the rays of light will fall upon this object, now you are going to get here the view, the image or the shadow of that object. Okay, so this is basically termed as projection. In projection, the 3D object we are plotting on 2D plane. Okay, so next. Okay, so this is all about whatever I was talking right now. That is, see, the projection of plane. Okay, the plane of projection. So here is the in between, here is the object. Okay, and here is the line of sight. So the observer is seeing from here, right? So observer is seeing, so that is the line of sight, right? So that is the line of sight. The object is in the middle, and here is the observer. He is just seeing that object. So here we are having what? The line of sights, right? And the view is being projected on the plane. So this is our plane of projection. So why we say it a plane of projection? Because the image is formed on that plane. So the plane which have the image or which have the view, that is known as plane of projection. So now let's start our main topic, the projection of points. Okay, so before coming to the projection of point, you should also know about the notations. Why I am saying the notations? Because when you represent the 3D object on 2D paper, right, you drawing it on our engineering sheets. Okay, so engineering sheets. So how engineers may be knowing that you have drawn? See, let me explain you once again. Suppose I'm having this mobile. Okay, so now I have to draw this is images. So the front view, the top view, the side view. So if you see this mobile, okay, so here we are having the top view. Top view will be from here. Okay, so here will be the top view, and from here it will be the side view. Okay, or see, okay, let me explain you more clearly so I won't confuse you. Okay, if observer is seeing from here, see, okay, so it is the front view for it. Okay, if you're seeing it from the top, this is your top view, right? If you're seeing it from the side, so it is the side view. Okay, now you would be able to clear, right? So now this you have to draw on the sheet. So how engineer would be knowing that the sheet which you have drawn on that, it is the top view or it is the front view. So for knowing that thing, that for getting the proper understanding of that, we used to write the notations. Okay, so you have drawn a figure or you have drawn an object on 2D. Now you are writing it, you're naming it basically. Okay, so you're naming it like you see from here, the view, top view, front view and side view, the point. So so if I am making the front view of a point, I will represent it by the A dash. If I'm making the top view of the point, then I will make it as A. Okay, then for the side view I'm going to write it as A double dash. Okay, so this is the representation. That means if I am making the projection of point, okay, that is our main topic, the projection of point in which we are making. So suppose you just understand, or for an instance, suppose this is a point, my hand, this, okay, this is a point. So now I am going to write, okay, and I am going to make its view. The images I am going to make it, where I'll make the images on the plane of projection. Right now I will represent it as like, if I'm making a point, it is above, it is below, where the point is. Okay, the point which I have drawn, I have drawn it the front view or top view. So that all the things I'll just write it in the notations. Okay, like this. Similarly, see, for the line you are going to make the notation. Line will be line segment. You know the line segment, what it is, which has two endpoints, so A and B. So it will be having a point A. Suppose this line is having a point A and B. Okay, so this is the top view. So top view, for top view you are going to write AB. For front view you are going to write A dash B dash. For side view you are going to write A double dash B double dash. Okay, I hope you got this clear. Now coming to the next. Okay, so we are having the 9 type of projections of point in space. So 9 cases there is for that. Okay, so you understand here. See, we are having a quadrant. Okay, in first quadrant above HP, in front of VP. In second quadrant above HP, behind VP. In third quadrant below HP, behind VP. In fourth quadrant below HP, in front of VP. In plane on VP, above HP. In plane on HP, behind VP. In plane on VP, below HP. In plane on HP, in front of VP. In plane on both HP and VP. So these are the following cases we are going to plot. Okay, so see, for this only I was talking about. Okay, now you see, you already know that in 2D when you make, okay, 2D when you make, so we are having a horizontal, we are having y-axis, we are having x-axis, right? So this, like this we are having. So you just see in the figure also, you are having this x-axis and y-axis. So now the x-axis is called as HP. The y-axis is called as VP. You already know first quadrant, second quadrant, third quadrant and fourth quadrant. Okay, now you also know that the observer will be seeing from this side. See, just it's given in the figure itself, right? Now, okay, now this 2D thing I'm going to plot it in the 3D. Clear? I'm going to plot this in the 3D. So this 3D I have made here. Okay, so you just see the VP. This is the horizontal part is HP, okay, and vertical part is VP. So vertical plane. So here now in 3D we are going to term it as planes. Okay, so vertical plane is VP and horizontal plane is HP. So the intersection of both horizontal plane and vertical plane is going to be defined as a reference line. What is reference line? X and Y. Here you can see the reference line. Okay, now what I'm going to do here is we are having the topic projection of point. So now I'm going to make the projections of a point in each quadrant. I'll take the 9 cases. Okay, so I'll take the 9 cases here and we'll make the projection of the points in which they are located, right? So for first quadrant, okay, then second, then third, then fourth. Okay, now here we used to term, means we are having the terms like if a point means, we don't say like this that the point is located in first quadrant, point is located in second quadrant or third, fourth, like whatever. Okay, we don't say it like this. Then how do we locate a point? So there is a technical term, like we just define a point. If a point is above HP, so when you have to define it, that point is in the first quadrant, you will not say it the point is in the first quadrant. You will say point is above HP and behind and in front of VP. Okay, so this is in front of VP, so this is for first quadrant. In second quadrant you will say it like this, that point is above HP, okay, and behind VP. Clear? Okay, now for third quadrant you will say point is below HP and behind VP. For fourth quadrant you are going to say it as the point is below HP and in front of VP. Clear? Okay, so let's have our position number 1. Okay, first quadrant. Okay, now look at the point where we are locating the point. It is above HP. Clear? Okay, above HP and in front of VP. So this is the first quadrant. Yes, you defined it right. First quadrant. Now you just look, you just see about, you just have a glance on the 3D model. Okay, so here you are having the XY line. Okay, now you are having the point in space that is above HP and in front of VP. Clear? Now we have made here its projection. Okay, now in 3D, okay, point is above HP and point is in front of VP. Now you have to make it very sure, very clear, that now this 3D we are going to make it on 2D. Okay, we have to plot this on 2D. Now for making it 2D, what we used to do, we used to rotate the horizontal plane, okay, in clockwise direction. Okay, so what we are going to do is we will rotate this horizontal in clockwise direction. Okay, you got it? So when we'll rotate, okay, now this is suppose this is VP, okay, this is HP. Now you have to rotate it clockwise direction, okay, 90 degree, right? So it will be like this. See, just in 2D, the XY line. So the point which is above HP, okay, it has made what? Front view, top view, front view. Okay, because A1 dash is the front view and A1 is the top view. We have studied about the notations, right? So this is like this. So the point front view will always be on the VP. Front view will be always be made on VP and top view will always be made on HP. Okay, so here you get the conclusion. Okay, front view above XY, top view below XY. Clear? Now coming to the next. So what will be your next case for like this? Our next case will be the position number 2 and it will be in the second quadrant. Okay. See. Now the second quadrant. So where is the point? Where is the point? Point is above HP and behind VP. Clear? So so in 3D you can see it like this, point is above HP and behind VP. So okay, now where its front view will be made? Front view will be made on VP and top view will be made on HP. Clear? Now you cannot keep it as 3D because we need to draw this projection of point or projection of plane or projection of straight line, anything on the engineering sheet. So for making it on the engineering sheet, we need to make it on 2D, right? So we have to rotate HP and HP in clockwise direction. Okay, so rotate this HP, so it is like this somewhat. Okay, so when you will make it as a clockwise direction, what will be done? It is going to be overlapping. Okay, it will overlap. So your this will be made in 2D will be, so our front view will be, front view and top view both will be what? Above XY line, that is above reference line. Okay, because it's going to overlap, the both the planes will be getting overlap. Okay, so this is, so finally in conclusion we can say that front view is above XY and top view is also above XY. Clear? Okay, now coming to the next, position number 3. Similar, we are just taking the point, okay, in the space, and below, above, on, in, just like that. Okay, so we are taking the cases of that. So see, the third case is below HP. Okay, so in 3D it is below HP and behind VP. Okay, now you rotate this horizontal plane clockwise. So will it overlap or not? No, it will not overlap. Okay, it will not overlap. So where our front view will be made? So our front view is going to be below XY. Okay, and top view will be above XY. Okay, so this will be made on 2D. Now for the fourth case, in 3D you can see on the image you will be getting it crystal clear. Okay, crystal clear, right? So in 3D, point is below HP and point is in front of VP. Okay, so now in 2D both will be below XY line, that is a reference line. So in conclusion we can say that front view is below XY and top view is also below XY, because horizontal plane will be rotated clockwise direction. Okay, so it will be overlapping. Next case, okay, so above HP. Okay, so our point is where? Point is above HP. Okay, so this is above HP but in VP. See, just you look at the model, 3D model, so you would be able to you will be able to get it very quickly, because you have studied all the 4 cases, okay, which were the basic and main. Now you can make any of the cases. Okay, you can solve as many as questions upon this and you would be able to get clear. So for here we can say that in 3D the point is above HP but in VP. So where our point will be made? So in 2D we are going to make it as a front view above XY and top view on XY. Okay, so top view will be on XY. Okay, and front view will be above XY. The next case, okay, now here the point, so, okay, so before the point was above and now the point is below. So now the point is below HP but in VP. Okay, so in 2D you are going to make it as on the front view. Where front view will be? So front view will be below XY and top view will be on XY. Okay, so you'll make it as on XY and you'll make front view below. Okay, now how much mm of line you have to make, or at how much distance the point you have to make, everything will be given in the question. Just you have to read the question, you will get it very nicely. Okay, now coming to the next. So our position 7th is in HP. Okay, so this before the cases which we have seen, it was in VP, right? Now the cases are coming for in HP. Okay, so the point, so okay, now you see in this 3D you will be you would be getting that it is the point is in front of VP. Point is in front of VP, right? Now point is in HP, point is in front of VP and point is in HP. Now in 2D how it will be? Top view will be below XY. You can easily see here top view is below XY and front view is on XY. Now the next is the point, okay, will be in HP. Again it is in HP, but now this time it is behind VP. Okay, before this it was in front of VP. Now this is behind VP. Just it's very easy. The case is very easy. See, the point is behind VP, point is in HP. Now in 2D the top view will be above XY and front view will be on XY. Okay. Okay, now the position number 9, this is our last. Okay, so the point is in HP and point is in VP. Okay, so the front view and top view will be also where? On XY, on reference line. Both will be plotted on XY. Okay. Okay, now you have studied all the cases of projection. Okay, you know that where the projection has you already know that. Okay, we are using projection in various fields. Okay, it has very diverse. Okay, it has a very diverse role of projection. Like here you can see, okay, in the applications, the architectural field, we used to make the blueprints, we used to make 3D models, renderings, okay. So it's very very important, you know, like if we are constructing a house, okay, constructing a boat, constructing a ship, any of the material like this, okay, the architectural things, we are making a house, or we are just making a land, so we are just seeing it like it will be, how it will be from the front view, top and side. Or you're creating any product for any company, just like for instance, you're making a product for a US company, okay. So they have given you about the top view, front view and side view. Just it's because we already know that the engineering drawing is just like a medium of communication. The engineers communicate in this language itself. So what the Indian will be, easily the Indians who knows this language will easily make that product, okay, from the raw materials. Now you see, it has also the great application in the art, perspective drawing, creating realistic images, okay, and engineering as CAD model simultaneous, and all the visualizations, okay. So in engineering, as we know that we study engineer, okay, as an engineer we know that the its importance and its use, it is made, it's very very useful, very useful in engineering field. Okay, so in conclusion, we can say that the projection plays a crucial role in various fields, enabling us to represent and understand the world in two dimensions, right? Because we know the world in three dimensions, but now how does the seeing the object, okay, so now you're seeing any object, now you have to make it on, like how this object will be look like, will appear in front view, how it will appear on top view, how it will appear on side view, right? So what you're creating 2D images, okay. So you're understanding the world in two dimensions. It's very very important and very crucial, and it has a great advantage. As you know, the technology continues. So technology is going to continue in okay, and it will get advanced in few years, okay. So we can expect more sophisticated and realistic projection techniques in the future. So here it is said that in future, okay, for making the projection in 2D also, we will be having so many applications, so many, you know, apps or softwares for it will be created, okay, for making it. So it will be very easy for us to make 2D, okay, so to make projections. So overall we can say that projection is very crucial and it plays a vital role in our lives as well. Now, by the end of this presentation, I would like to thank Sub Lieutenant Rohit Soni sir for giving me the wonderful opportunity for giving the presentation over here. Thank you so much, sir. And thank you so much for everyone for listening the presentation so patiently.